In lesson 1.4, we're talking about function composition, so taking two functions or more than two and doing different things with them. First, let's talk about adding two functions. It can be written two different ways where you'll see either f plus g of x, which means add f and g with respect to x, or take all of f plus all of g. I think it's easier written this way, but these are equivalent instructions here. So what this wants me to do is take the f function, which is x plus 2, and take the g function, which is 3x plus 2, and add them together. So what this wants is me to take x plus 2 plus 3x plus 2, and then here we would just combine like terms, so we would get 4x plus 4. That is f plus g of x. So here they want us to take the f function minus the g function, or f minus g. So we're going to take the f function, x plus 2, minus 3x plus 2. Now I'm putting parentheses on this one because when you do subtraction, you have to subtract everything. You can't just subtract the 3x. You have to distribute this. You have to subtract the 3x and the 2. So we've got x minus 3x, which would be negative 2x, and then 2 minus 2, which is 0. So that is what we would get, negative 2x. Here, if there's a dot, which means product, here we're multiplying f times g of x, or f of x times g of x means the same thing. That wants you to take your f function times your g function. And in this case, to multiply, you would need to do FOIL. So first times first is going to give you 3x squared. Outside is going to give you 2x. Then we've got inside gives us 6x. And then last gives us 4. And then we can combine like terms. So we get 3x squared plus 8x plus 4. And then our quotient, f divided by g of x, or f of x divided by g of x, given that g cannot equal 0, that just wants you to take the f function and divide by the g function. So x plus 2 over 3x plus 2 would be our answer. And it says given the restriction that g cannot equal 0, so let's say what would make the bottom 0? So if we subtract 2 and divide by 3, negative 2/3 is what would make this 0. And what I just did was I set that equal to 0 and I subtracted 2 and divided by 3. That's the x value that would give you 0, so it cannot be part of the domain of the function. So what if we have f of g? So if there's an open circle between them, that's wanting you to take the g function and put it inside of the f function, which I think is easier to see when written in this notation. F is on the outside, g of x is inside of that function. So, and you can tell that when there's only one x. So f of g of x, where a difference is, people will think this is multiplication, but up here we see this is same notation, but asking for something completely different. This is f of x times g of x. There's two x's, so we are multiplying. Here there's one x, f of g of x, meaning take one function and put it into the other, not multiply. So what this is saying is take 2 and plug it into g. Take that answer and plug it into f. So first we're going to take 2 and plug it into the g function. And we get 8 minus 1, which is 7. And now it's saying take 7 and plug it into the f function, which would give me a final answer of 10. So we took 2 and plugged it into g, and then we took that answer and plugged it into f and got 10. So here it's saying take negative 5, plug it into f, and then take that answer and plug it into g. You're working from the inside out. So we're going to take f and plug in negative 5, which gives me negative 2. And then we take that and we plug it into g. So g of negative 2, I plug in negative 2 into the g function. and that gives me -8 minus 1, so -9 is our final answer. So again, we took -5 and plugged it into F, and then we took that answer and plugged it into G. On C and D, they don't have numbers to plug in. You're just plugging in the function. So it's saying leave X alone, so G of X, and plug that into the F function. So if we leave X alone for G, that's 4X minus 1, and we're plugging it into the function. So we got to figure out, well, where's the input for F since we're putting G into F? The input is the X variable. So what I do is I leave parentheses for the input variable. So that's where my input goes. That's X plus 3. But instead of X, we're putting G in there. And G is 4X minus 1. So the G function went into the input variable of the F function. And then we just combine like terms. 3 minus 1 is 2. So that is F of G of X. Here it's going the other direction. It's wanting F function inside of the G function. So I'm going to write down the G function and leave the input variable alone, or give it an open set of parentheses. So instead of 4x minus 1, and I'm talking about this, 4x minus 1, I leave x empty, and now I put the F function inside of it. So x plus 3 goes in where the input is. Now on this problem, to simplify, we need to distribute that 4 and then combine like terms. So 4x plus 11 would be the answer for D. We're doing similar things on the back, just written with the open circle instead of the F of G of X, but it means the same thing. If there's an open circle, this does not mean multiply. This means take 1, plug it into G, take that answer, plug it into F. So let's take 1 and plug it into G. And here I'm getting 2 minus 1, which is 1. And then I'm taking that and plugging it into the F function. So I'm not plugging in 1 because of that 1. I'm plugging in 1 to F because of the answer I just got from G. So now I plug 1 in for F. And we get 3 plus 2, which is 5, is the final answer. So here we're going the other way, plugging 1 into F, taking that answer and plugging it into G. So take 1, plug it into F. We just did that. We got 5. And now we take that answer and plug it into G. So G of 5. And so that's going to give me 25 when you square. 25 times 2, so 50 minus 1, we get 49. And then C wants you to take -2, plug it into F, and take that answer and plug it into F again. So we're going to have -2 going into the F function. And that's going to give me -6 plus 2, which is -4. Now we take -4 and plug it into F. So that gives me -12 plus 2, which is -10 for the final answer. In example 3, we are finding inverses. And so to find an inverse, step 1 is to switch your input and your output variables. So we change y into an x, and we change x into a y. And that is your first step. And technically, we just found the inverse. We just need to clean it up and solve for the y. So notice everything is the same except y became x and x became y. That's the first step. Now your next step is to solve for y. So we're going to add 9 to the other side. And then we need to get rid of the 3/4, so we multiply by the reciprocal. So I multiply both sides by 4/3, which needs to be distributed. And so we get y equals 4/3 x plus, if I multiply 9 by 4/3, 9 divided by 3 is 3. and then 3 times 4 is 12. So this is my inverse. Now, this one said y equals, so if we're writing the inverse of y, we should put a little notation on the y. This is the inverse of y, so we put a little -1 in the top corner. Now that's not an exponent, it's just a notation. So this says inverse of y is 4/3 x plus 12. So we're going to do the same thing here in B. Step 1, change your x and your y, switch your input and your output variables. So we've switched x and y, so that's my inverse so far. And now we want to solve for y. So right now y minus 4 is trapped inside of a square root. So we're going to square both sides to get it out of the square root. So I've squared both sides. Now the radical's gone. And now I can add the 4 to the other side. So x squared plus 4. And now this is my inverse, and let's put a little notation there to show that I started with y, and now this is the inverse of y. Now, verifying inverses. So here they're giving you two functions that are possibly inverses of each other. And in order to check, you plug in g into f, and then you plug f into g. And in both cases, you want to show that it equals x at the very end. So you want y equals x at the very end. And if not, then they're not inverses. So here, this is saying plug g into f. So we're going to take the f function, and I'm going to leave the input variable alone, empty, and I'm going to plug g into it. So we plug g in there, and then we simplify. So here, parentheses don't matter because we're just adding. So I can put the 8's together, and the 8's end up canceling. And then I've got square root of x squared, which just cancels my square root and my square, and I get x, which is what we want. But we also have to show the opposite. We now have to plug f into g. We have to show both. So now I'm going to write down the g function, leaving the input variable alone, or empty, and then plug f inside of it. So in this case, the square and the radical cancel first. Then the 8's will cancel and make 0. And so, yes, they are inverses. Because we got x in both cases. For B, let's do the same thing. We're going to plug g into f. So I'm writing down the f function, leaving x alone. And now I'm going to plug g inside of it. So if I were to distribute here, I end up getting 2's cancel, 3's cancel, so we get x. If I distribute 2/3 onto my 4, I'm going to get -8/3. And now 4 and -8/3 do not reduce down to x, so these will not equal x. And that means I don't even need to test this one. So this is not inverses, because I cannot get it down to just x.